Hello everyone and welcome back. I'm here with another exciting video. Today I have this dovetail thing again. There's a couple of things I want to do with it. If you've been watching the channel for a few years, then you'll know what this is all about. Yeah, that's right, the original post of this one was a few years back on the old Thingiverse page, which I guess is now my mini factory. The same model can also be found on my printables page, which is still the same old printables. Now I want to move it to my Makerworld page. I've been a bit behind on updating Makerworld with all the models that are on all the other sites, and I want to keep bringing it up to speed. The main reason being is that their rewards program is just so great. If I make this model unique enough, it could also join their exclusive model program too, where the incentives are pretty tempting. Come to think of it, this model also uses some purchase parts, these 3 dowel pins. Makerworld has their own supply store where I can source these from. This store is full of all the little components generally used in 3D printing. After a bit of scrolling, I get to the M5 stainless steel dowel pins, and the ones used on this project are 6mm. Well, that's not the end of the world though, because I have design skills and can adapt it to work with a 5mm. At least they have an assortment of sizes available, and the 12mm length should work just fine. Goal time. I'm going to try to change this one enough and squeak it by as an exclusive model to Makerworld. I want to also list some maker supply components in this build. Then I also want to eliminate any post-processing I had to do with this model at the design stage. So my previous attempt at a Makerworld exclusive model was this coaster set. Around the holidays I worked hard at getting these designed and posted, all to eventually find out that there was an exclusions list I didn't know about, where the coasters were directly called out. But that's not going to stop me from trying one more model. Alright, so this thing's a puzzle, and before I just go show you the inner workings of it, I have to warn you. Everything from here out could spoil the solution if you're looking to find the solution yourself. So, let's get into it. What looks like a dovetail from the outside is really a circular feature that guides the two parts together. It's then locked by 3 individual dowel pins, but it doesn't come apart once engaged by sometimes simply picking it up. But the existing design uses 6mm dowels, and I guess the first thing I'd like to do is represent it with the 5mm dowel pins just to see how it looks. There they are, and oh boy, there's a bunch of clearance there, which kind of has me worried a little. Any excessive play here could quickly give away the secret of how it comes open. I think the only way to fix the excessive play here is to reduce the hole diameters in the 2 dovetail parts. Now I don't really know what the diameter I need here, I'll get to that in a minute. But I do know that I want to avoid any cleanup of the horizontally printed holes. It's just an unnecessary step if it can be designed out. The problem comes with the sag at the top of each hole when printed horizontally, and the potential that it just isn't round at all anymore. So I decided to make up a set of test pieces to compare a few things. That's right, using a little bit of material to save a lot of material. I'm going to start with a 10mm by 10mm by 15mm block. From there I'm going to put the horizontal 5mm hole in and extrude cut it to a 10mm deep, just so that I can retrieve the dowel and it doesn't get stuck forever. This way I'm always guaranteed to have 2mm hanging out that I can grab onto. From there I just want to add some 1mm chamfers to all the corners so it's easy on my sensitive hands. It took me so long to design that piece that the dowel pins finally arrived from the maker supply. The first thing I noticed with these new dowels when I compared it to the old ones I've been using for these was that the ends were pretty squared off. The old ones had a pretty nice radius on the ends where these new ones might get snagged on any edge. So I added a lead-in chamfer to the test block's hole to hopefully avoid any issues in this area. Almost done. The only other thing I did was add a label to it. I made a few sizes of these, starting with a 5mm diameter, then increasing by 0.1mm increments up to the 5.5mm diameter. Throw them over to the slicer so I can print them from my generic Overture PET G, and in about a half hour I'll be back to see how they came out. The little workhorse just got done with the first layer, and so far so good. Flash forward here real quick and they're all done. Let's get them off of here. I'm anxious to see what diameter works the best. All the prints came out good. The only thing I'm not happy with is each one's label. The 5 kind of fused into a 6. But they're just for testing. I know what they're all supposed to be. I can tell already that the tops of the holes have quite a bit of sag. I don't have my expectations too high for these. The holes all turned out as what look to be ovals. Each one has these ribbons of material protruding into the hole as well. This honestly doesn't look good for what I'm trying to accomplish here. The show must go on though. I have to follow through with the testing, even if it's for nothing more than a comparison point. Starting off with a 5mm, I don't expect this pin to just fall into the hole. And it didn't. So at least I got something right so far. Moving up to the 5.1mm horizontal hole. This is where anything could happen. It got as far as the end of the infeed chamfer, but that one's in the no-go pile as well. 5.2mm. Let's see. Quite a bit of force to get it into the hole, but it does go. So this might end up being a simple video after all. Oh, it's pretty stuck in there. Looking promising, but not there yet. Next step is 5.3. Similar, it goes in a little bit easier as expected, but this still won't work with the design goal here. This pin needs to basically free float. Starting to run out of test blocks here. The 5.4mm was easier yet, but there's still quite a bit of resistance on the dowel pin. Last one, 5.5mm. This is the freest one yet really, but there's still an unbelievable amount of friction here. The pin doesn't just slide around like I want it to. Looking closely at the 5.5mm test block, I can see that there's visibly too much sag in the top layer of material, not to mention the hole is still oval. I could keep making the hole bigger until the dowel fits the way I want it to vertically, but the horizontal dimension is what I'm worried about here really. In this application, if the hole has too much clearance horizontally, it can give away the entire puzzle, or at least get anyone easily one step closer in finding how it comes apart. I need to develop a new plan. I actually think I might have an idea for what to try next. I'll just turn on supports. I mean, these things fix any overhang, right? This way here, the top edge of the hole won't be able to sag at all. The theory here is that I'll end up with a perfectly round hole. The same exact 6 test blocks without any changes at all, just the addition of supports in the slicer. All done, let's get these supports off. Coming off pretty clean here. Oh no, I added one deep on the inside. That'll be fun. Luckily I have this pick handy to just dig them out. Come on, you little bugger. Perfect. Let's just get the rest of them out here real quick. I can already tell that these things are going to be trouble just looking at them. The interface here where the support was is kind of messed up. I can honestly say I don't have high hopes for these, even though I thought the supports were the solution. But hopes don't mean diligence. Let's try to throw the dowel in there to see if these work any better than the unsupported holes. Starting with the 5mm again. Nope. There's just this obvious burr at the top too. .1 is another no, same as last time. 5.2, 5.3, 5.4, all too tight still again. 5.5mm doesn't look too promising either. There's just so much drag here. If I were to just use this in the design, if the pins ever do lock, they're never coming apart. Looks like what I thought was the fix just ended up making everything worse. Just comparing this to the 5.5mm without supports, the no supports actually feels like it has less drag in the dowel. They're just so close to each other that I can't really tell that anything changed between adding supports or just using the bare hole. Bruh. If I had to choose one at this point, I guess it would be the support-free version. At this point, I just felt like giving up. And while I was in the process of drowning in grief and giving up, I came across this TikTok. It made me realize that I was doing it all wrong the whole time.
The circle.
The square hole.
Non-round pins are used all the time in holes for location purposes, but I don't have any of these pins. My pins are round. But wait, I have a 3D printer capable of making things that can't be done with traditional machining, where diamond shape is now possible, so I have to try it out. Just gotta get this pattern across all the sizes and I'll have another set to print out and test with. And as I put it into the slicer, I can see that supports are not a requirement, as all the edges taper up at 45 degrees with a very tight radius at the top, which, if it sags, shouldn't interfere with the dowel anymore. Looking good. Let's get these normal ones out of the way here and make some room for the new design. Alright, starting off with a 5mm block again as a baseline. I know it's not going to fit, it shouldn't fit, but I can already tell that the transition inward to the hole feels a lot cleaner. It's almost fitting, really. Alright, 5.1mm. What? It went in. I didn't expect that so fast here. I must be dreaming. Let's see that again. Yep, pretty clean. Okay, well there you have it. 5.1 millimeters in the diamond shape outperforms any of the supported or unsupported round hole designs. That's incredible. Now I want to see the rest. 5.2 millimeters? It actually feels really loose. I mean, this dowel is just falling out when it's tipped slightly. I think I'm onto something here. Already, without even checking the rest out, I think I have some contending sizes for this hole design. Just jumping up to the 5.5 millimeter to see how that one performs. It's way too loose here in my opinion. There's a ton of sloppy side-to-side movement in this one for how I want the finished part to function. The 5.2 millimeter also has a touch more side-to-side motion than I want. In the finished design, I'm afraid that any excessive side-to-side motion in these holes will instantly give any puzzle solver a significant leg up in solving the puzzle. And we wouldn't want that, would we? So I guess I'm somewhere in between the 5.1 millimeters being slightly too tight and the 5.2 millimeters being slightly too loose. The 5.1 millimeters needs a bit of motivation to really release itself, and I can feel a slight drag against the dowel as it passes in and out. The 5.2 millimeter works well, but it could be a little bit too loose for my liking on this one. Just to recap here, I started off with an unsupported horizontal hole, and the largest size I tried at 5.5 millimeters did not work. Then I thought that simply adding supports to the hole would solve any problems here. It did not, and in my opinion, it may have made the fit even worse. Then with the help of TikTok, I was able to find a new solution with a diamond-shaped hole made possible with 3D printing. The largest size in the unsupported horizontal hole could work for some applications, but not this one. There can be no drag on this pin. Also, the largest size in the supported horizontal hole possibly had some remnants of the supports left in there, creating an unforeseen resistance on the pin as well. Both of these would need some post-print cleanup to get working properly. Then the diamond hole, where only a slight increase in hole size over the 5mm worked perfectly. So for horizontal holes where they need to accurately carry a sliding pin like this, there's no other option in my mind. This diamond shape just works. Time to get into the redesign. Looks like I may have my work cut out for me here. First thing I need to do is jump into one of the hole sketches and change this hole to somewhere in between 5.1 and 5.2 millimeters. Then I'm going to convert that previous model geometry to a construction line so that it can be used as a reference. Using a center rectangle, I'll just sketch a square roughly off kilter by 45 degrees or so, making one of the edges tangent to the edge of the construction circle, then the other edge tangent as well. Then take one of the construction diagonals from the square and create either a vertical or horizontal constraint to it. Boom, diamond. I want to add some small radii to each of the sharp corners. Just for aesthetics, they're not really functional. Reapply my 1mm by 60 degree lead-in chamfer. Then it's just a matter of making sure any new features get repatterned around with the circular pattern I used to distribute it evenly around the model. On to the next piece here, where it's kind of the same process, just backwards, and in the inside of the dovetail cutout. 1mm radius in the corners. Then the inlet chamfer. These things are always confusing when they're not 45 degrees. Flip direction. Okay, there it is somehow. Looks good to me. Pattern it around and good to go. Just gotta check it out real quick to make sure everything maintained alignment. Quick measurement, and of course I didn't pick the one that lines with the XYZ planes. Anyways, it looks like everything lines up here to me. But the thing that I see, and that probably doesn't even matter, is that the dowels lost all their mates. The hole isn't there anymore. So I just have to add some symmetric mates between the two planes of the dowel and the edges of the diamond hole. And like I said, this part doesn't matter, but it drives me nuts to see broken mates in an assembly and unconstrained items. So I just gotta fix it real quick. There it is, all done. The pins are a little bit shorter than the previous one, so they actually retract a little bit further into the outside block than what I would like to see, but I think it's a reasonable thing to leave how it is. So I guess I'm done here. Oh wait, I just want to do one more thing before I send it off to the printer. I want to put a graphic on the large triangle sides just to dress them up a little bit. For that, I'll start a new sketch on this side right here, then drop a sketch DXF onto the surface. For this one, I think I'll put a gift on it so it can pass as a puzzle gift box and let people know there could be treasures on the inside when they pick it up. I'm not going to go through all the details of the DXF creation and modeling of the different solid bodies in this video. If you want to see the full workflow on doing something like this, check out the Christmas coaster video I made a little bit ago for all the details. And here it is, the finished Dovetail puzzle gift box with a compartment on the inside. But this is just a model now, what am I going to do with it? Give it away to someone as a digital file on a thumb drive? No, I have to print a physical thing to gift away. So in the slicer that recognizes the different solid bodies, I just need to use the paint tool to tell the AMS what filament positions I want to use for this. Then for the best results on the surface images, I want to make sure they are all facing down. Come to think of it, these parts need to be printed with the image face down anyways due to the support for redesign. Oh, what's next? Position them appropriately on the build plate. Wait, there's a tool for that. Boom, good to go. Slice it up real quick and it looks like I'm at 5 filament changes in just under 3 hours of total print time using PETG. It's finally time. The first part of the first layer is looking fantastic. This printer hasn't disappointed me yet. Switch over to the white with a massive purge block. Then the second part of the first layer went down perfectly as well. It actually might be 2 layers on there at this point, but it's looking great so far anyways. Flash forward to the finished parts 3 hours later. Perfect. Here they are, 2 pieces, both black and white graphics and no post-processing done at all. Straight from the printer. They seem to fit perfectly together, just how the original design did. No surprise there really, but that's not what I wanted to test. I want to make sure that the new diamond holes work well with the Maker Supply dowel pins. Let's get 3 of these things out and give it a shot. Oh wow, that just went right in there, just like the test blocks. This is fantastic. Let's just get the other 2 in there and push them all back so they're fully recessed. Then grab the inside dovetail piece and hope everything lines up. This part is always nerve-wracking for me. It's the moment of truth, right? I mean, if these things go together and the pins lock it up, I'm never going to be able to get it apart again. The pins shouldn't move until I tilt it a little. If I leave it exactly horizontal, everything should just still move indefinitely. But the moment I stand it up on any one of its sides, one of the pins slides down into one of the center holes, preventing any easy form of rotation to open it back up. I think it was a good choice too with the clearance. There's minimal side-to-side motion that would give away that the pieces need to be rotated to open. It moves just enough to show that the pieces are separate and capable of being separated without showing necessarily the direction they need to move in relation to each other. There it is, I guess I'm done now. Ha, I'm not done yet. I decided to print 2 more pieces with inverted colors. Pretty simple, the same print profile, just different filaments. I also added a little bit of brim to each of the sharp corners since I noticed an ever so slight lifting in the previous ones. 3 more hours of printing and I have these 2 pieces now to use. Believe it or not, I have a faint plan here. I want to share the pieces of these 2 with each other. But before I can do that, I guess I need to show you how to get this thing apart. In order to get all 3 of the pins out of their locking positions at once, I need to apply some centripetal force to them. The whole assembly just needs to spin fast. Might take a couple of tries depending on if any of the pins are pinched or not, and if anything external is struck in the process of spinning. I still don't even know if this one is capable of separating. I hope all the pin clearances are good on it. I might never get it apart. Starting to get worried here. There we go. It actually wasn't that bad with flinging it in the air. Came right apart. Okay, now I just want to interchange this top part here with the inverted color print. Fits right in there. And just like that, it's locked. That's scary fast, but cool. Works just like it's supposed to. 3 more dowel pins to get the other one together. And voila, a little shake and it's locked together as well. In Makerworld, I'm also going to add the blank version of this in single solid color just in case anyone wants to print some plain ones out, or include their own graphics or logo. I guess what I would recommend here is that you print a set from one color and a set from a second color. That way you can exchange the halves from the 2 and have your own multicolor set without using AMS that printed without any graphics too. From a bag of 10 dowel pins, I'm able to get 3 complete puzzles with 1 pin left over from the 10. If my quick math is correct, I guess that means that 3 bags of dowels would create 10 total puzzle assemblies without any pins left over. This set of models I'm only posting to Makerworld since they're designed to use components available from the Maker Supply store. Hopefully they accept it as part of their exclusive program. We'll see. To make it easy for you to find, I'll put a direct link in the description of this video so you can jump right over to it from here. I originally did a video on this model as the third YouTube video I ever posted. It's kinda cringe, but if you want to go check it out and learn more about it, about 5 minutes in is where it gets really good. Thank you everyone for watching this far, and if you did make it to here, leave a thumbs up or a comment or something to let me know if you enjoyed it or not. See you in the next one.